All right, so this is the last part of our review for the final, 53 to question 60. So if you feel really confident up until this point, you're in good shape. Also, if you're watching this video because you were absent, you are allowed to use one full sheet of paper front and back with whatever notes that you have for the final. The only thing about that is you have to turn it in to me when you're finished with the final. Yes.
Can it be typed?
Can it be typed? Yes, but I'm assuming that not all of it will be typed because you're going to have some graphs and things like that. So, yeah. But I do need it after the test. Okay. So, for number 53, what do we do to solve for x? Add 5x on both sides. I think it's a little silly that they put this as 53, but why not, I suppose. X equals negative 8. We can double check and see that that will work. Any questions? I don't know.
Absolutely not.
I think, you know what, I think the moral of 53 is we don't want you to fail. So don't come in here thinking like, oh, she wants me to fail or whatever. No, we want you to do your best. So as long as you try and you study, you should do fine. It will take some work on your part, but you do need to study. But none of us are aiming for you to fail. Okay, here we go, 54. Give that a try. See if you remember how to graph inequalities. This has to do with shading, solid and dotted, etc. All right, you will be asked to graph inequalities. So the very first thing you have to do is decide the type of line that you're dealing with. Am I dealing with a solid line or a dotted line? Dotted. How do you know? Yes. Exactly. It's less than, not less than or equal to. So this is nice. It's not like a piecewise where I have to graph part of the line. I have to graph the whole line. It's just dotted, and then I do some shading. So I'm going to start at my y-intercept at 3. Of course, this would be labeled for you. This is going by ones. So label that 3. Then you're going to go down 1 to the right one, as you know, or up 1 to the left one, and make a dashed or dotted line. Now remember, why do we shade? Yes. To show where the solutions are with an S, right? Because there are a number of x and y values that we can plug in that make this inequality true. There are a number of things that when we plug in an x and a y will be less than that x, negative x plus 3, right? A number of different points. So our job is to find all of those points by shading. Do you remember? Is this an above or below shade? Below. How did you know? Yeah, because it's pointing away from the y, so you're going to have to shade below the dotted line. So that means all of these points work as possible solutions for your graph. Another thing to do if you don't like the above or below thing, again, is to test points. So for example, we like to test points. We like to test the point 0, 0 as long as my line doesn't fall on 0, 0. You can test any point as long as your line does not fall on it. When you test a point, if it's true, then you shade towards the point. If it's false, you shade away from the point. So if we wanted to check 0, 0, we can do that because my line does not fall on 0, 0. So I'm going to check to see if that's true. Is 0 less than 0 plus 3? Well, 0 is less than 3, is it not? So I can shade towards the point 0, 0. That is another way to determine your shading if for some reason you don't remember the above or below thing. Any questions? All right. Give this a try. So we're going backwards here. And this is often easier than actually graphing a system and finding the shaded intersection. I say that because really we have to just determine what the equations of our lines are, and then change those equations to inequalities and the direction of our shading. So let's deal with the horizontal line first. That's going to be y is less than or equal to what? Yeah, y is less than or equal to 2. How did I know that it was less than or equal to? Yes. Yeah, the shading is going downwards. So that means that it's going to face away from the line, or yeah, away from the line, going down. How did I know that it was solid as opposed to dotted? Yeah, less than, I meant to say, how did I know it was less than or equal to? It's solid, right? Yeah. And then we have to look at the dotted line here, which it's just a matter of finding our y-intercept. This is a 1. So my y-intercept is 0, 1, or the value of 1. And then we have to find our slope. We'll just find another easy point, right? So I'm just going to go down. If I'm going by 1, again, double check and see the scale at which you're going. So I'm going by 1, so I'm going down 1, 2, 3. So that's negative 3. And I'm going to the right, so that's positive 1, 2. So I'm going down 3 and right 2. So putting that all together with the direction of the shading, what is that going to be? That's another now. Yes.
Y greater than negative 3 over 2x plus 1.
Yes. Y is greater than, because you're shading above, negative 3 over 2x plus 1. What questions do you have about that, if any? All right. We'll do a couple more and then we'll take a break. On this type of problem, one thing that I saw that was kind of a silly mistake, but easy to make, was not defining your variable. So it says, write the sentence as an inequality. The starting wage is at least $12 per hour. The very first thing you want to do before you make the inequality is tell me what x or y or a or b or s is. So I'm going to say that this is the starting wage. I said the starting wage is at least $12 per hour. So if s is our starting wage, at least then, what does that mean? Greater than or equal to. Greater than or equal to $12 per hour. And this is a very important skill, especially if you take a sports statistics class. I was overhearing a lecture the other day and they were talking about at least, at most, no more than, and trying to understand all of those differences and which ones are the same thing, saying the same thing. So I'm going to ask you, if that said, instead of at least, if it said at most, what does that look like? Yeah, less than or equal to. X is less than or equal to $12. What about no more than? What does that look like? Less than or equal to. So we see that at most and no more than are the same thing, right? Yeah, so those things, they do matter. They matter in statistics, they matter in mathematics in general. Okay, questions about that? Okay, take about 3 minutes. Okay, so now we're graphing a system of inequalities. So rather than one inequality and shading, we're graphing 2 or more. Remember, a system can have 3, it can have 4, it can have as many as you want. as long as I have more than one. Most of the time in Algebra 1 we'll be dealing with a system of two inequalities. So in this case, I want to graph the first line. Is that going to be solid or dotted? It's going to be solid. Is that horizontal or vertical? Horizontal. So I'm going to find 2 here, and I'm just going to draw a solid horizontal line. And actually, looking at how I taught this initially, I'll save my shading for later so that it doesn't get all confusing. So, is this going to be above or below when I shape? It's going to be above. I'm just going to note that here. It's going to be above. The next one, is that solid or dotted? That's dotted, so I'm going to find my y-intercept of 3. I'm going to go up 1, 2, over to the right one, or down 1, 2, over to the left one, and I'm going to make a dotted line. Dash, dotted, you know. Is that going to be above or below? Below. Alright. So this is going to be below, this is going to be above, the red's going to be below, the green's going to be above, so they're going to intersect. Right there. Don't you know? Yeah. So, in the word problems that we did in Chapter 5, which you will get your Chapter 5 test back on Monday, a lot of you had issues interpreting a solution. So, what this means is that when you have this overlap of shading, everything in the shaded region is a possible solution. You can pick a point and that would work for both of them. That's one possible solution among many. Alright? Do you have any questions? Yes. Oh, vertical? No, that's an X, right? And let's think about it. So this is saying, let's look at just a regular equation, y equals 2. This is saying no matter what x value I have, what's my y value always going to be? 2. And if you look at this line, that's what it says. My x value could be 1, my y value is 2. My x value could be 2, my y value is 2. 2, 2, 2, 2, 2, 2, 2, right? So that's why that makes sense. If you look at something that is vertical, which is an x equals, then that's saying that no matter what your y is, your x value is always 2, right? And so if you had a vertical line, these y values would change, but the x value would stay the same. Yeah? And speaking of x's, if you were to be given something like this, we're looking at up, down, or we're looking at left or right. Would this be left or right, the shading? Right, because it's facing towards the x. Any other questions? That was a good one. All right. Excellent. You're almost... This problem says you have 56 math and chemistry problems for homework. You have 14 more math problems than chemistry problems. How many problems do you have in each subject? Write 2 equations that represent the system, solve, and check. So, one of the first things we have to decide, since we've been dealing with inequalities and equations, is it an inequality or is it an equation that we're looking at? A set of equations or a set of inequalities? What did you come up with? Are these inequalities that we're looking at or equations? Equations, right. They're equal to an exact number. So in this case, you have a total of 56 math and chemistry problems. The very first thing we want to do is define what? The variables. So I'm going to use M for math, C for chemistry. In total, I have how many problems? So how will I set that up as an equation? Yeah. If I take my total number of math problems plus my total number of chemistry problems, I'll get 56 total problems. It says you have 14 more math problems than chemistry problems. So how can I express that? How can I express my math problems in terms of my chemistry problems? There's going to be, so the number of math problems I have, right? It's always that latter part, that second half is a little bit more confusing. So just think about it. Start with some variable. I'm going to start with math. So it says that you have 14 more math problems than chemistry problems. So the number of math problems I have is the number of chemistry problems I have. I have 14 more math problems. So it's the number of chemistry problems I have plus 14. Because I have more math problems than chemistry problems, do I not? So let's read that again. It says, you have 14 more math problems than chemistry problems. I have a greater amount of math problems. I have a greater amount of math, then I can express that in terms of the other one. Whatever I have the greater amount of, that's what I can express in terms of the other one plus something else. Does that make sense? So I have more math problems, so I can express that in terms of chemistry problems plus something else. If I had more science problems, I could express science problems in terms of my math problems plus something, or my chemistry problems plus something. Does that make sense? Okay, so now that I have this, how can I solve it? Now, it's a system. How do we solve systems like this? What do we use to solve a system like this? Yeah, we plugged in for m. What's that called? Substitution. I'm substituting a value in for m, or values in for m. And in this case, it's going to be c plus 14. So c plus 14 plus c equals 56. Again, I'm using substitution. Nothing different with the systems that I'm working with. I still have to decide, is it substitution, elimination, or graphing? And in this case, the easiest thing to do is substitution. So I have 2c plus 14 equals 56. Subtract 14 and subtract 14, and I end up with 2c equals 24. C equals 22. So my total number of chemistry problems is 22. How many math problems do I have? 30. Well, you add 10 and you add 4. So that's 32 plus 4 is 36. Okay. Does that work? No, it should be 34. You're right. Oh, well, sorry. Is that what I did? Yes. Okay. So chemistry would be 21, making math be what? Yeah. 35. Oops, sorry about that. It's my left one here. Yeah, 42. Yep, that's 42. So that should be 42. That should be 21. That should be 35. So I guess your lesson here is don't rush, because that's what I did this morning. But does that make sense? Good. And thank you for the correction, because I'm not perfect. It says solve and check, and of course we can check by just seeing that 35 plus 21 is 56. And then if we plug in 21 for C, we get, and then we add 14 to it. It makes sense with the amount of math problems being 14 more than chemistry problems. Any questions about that? All right. This should be pretty easy. What's the slope of that line? Yeah, it's 0. Describe the slope. 0. What is the slope? 0. 0. Okay, not no slope, not undefined, 0 slope. 0 is a placeholder. So 0 slope. And that is both our slope and a description of it. The last one. Let's see what they throw at us here. Solve the equation, graph the solutions if possible. Give that a try, please. How do I solve this? Yes. Split it into two, so what will that look like? X equals 5, x equals -5. Plug them in, do they both work? Yeah, they do. So just find 5. So 2, 5, 3, 2, 1, 0, 1, 2, 3, 4, 5. Dot. Dot. Feel comfortable with this 60 question? Great. That's your final pretty much. So what I'm going to do now